Today's episode is sponsored by Castrol. Visit them at castrol.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. If you haven't already, like and subscribe to get new episodes delivered to your inbox each week. I'm your host, Cary Gitter, Associate Editor at SME Media. In today's episode, we're exploring a topic that's often overlooked but absolutely critical to machining success: metalworking fluids. These unsung heroes play a vital role in tool life, surface finish, heat dissipation, and even workplace safety. But with so many formulations and applications, how do you choose the right one? Whether you're a shop floor veteran, a process engineer, or just curious about what keeps the gears turning smoothly, this episode is for you. I'm joined by two experts in industrial lubrication and fluid technology to help us break it all down. Brandy Brown, Area Sales Manager at Castrol Industrial, and Mike Kowalski, Senior Area Sales Manager and Certified Lubrication Specialist with the Society of Tribologists and Lubrication Engineers. Welcome to the show.
Thank you.
Thank you.
Great to have you here. So before we begin, Brandy and Mike, would you each like to just take turns describing a bit what your roles are at Castrol and your background in the industry?
Thank you for the intro, Cary. I would say that, our roles here, while we can wear many hats, our main goal is to bridge the gap to the experts. So thank you for introducing us as experts, but I would say that the experts really are all within Castrol, and especially for me and my region being in the Northwest, there's a wide variety of different types of manufacturing that goes on within my region, and being able to just connect the dots for folks and bridge that gap to the experts is where we can provide a lot of value.
Yeah, I think that's good, Brandy. And as you said, and also that we do wear many hats, and some of those are more of a commercial business side. And then the fun side, as I like to call, is the technical side, where we're actually showing up at factories, machine shops, steel mills, and those kind of things, and getting to have fun with the customers, and what kind of projects they're working on, and how we can be assistants. So it's an all around role, if you will.
Well, that skill of bridging the gap and explaining is definitely going to come in handy today. So we're so glad to have you both here to enlighten us on this topic. So let's start with the basics. We have a broad audience here. So for those who might not be familiar, what exactly are metalworking fluids, and why are they so important?
So, to make it an easy definition, a fluid is used at the point of contact between a tool and a workpiece, or the part that you're making. More specifically in our area, it's kind of with respect to the machining or shaping of metals. So a term coolant is kind of used interchangeably with metalworking fluids, and those are more designed and engineered blend of water, oils, and other materials that would provide a number of functions in the metalworking process itself. Some of those more important ones would be like to, say, lubricate the tool and the workpiece, as you're making it. Also, cooling at the tool workpiece interface. Chip removal is very important as you're cutting metal. And also, finally, kind of surface protection against corrosion is how you want to kind of end that a little bit.
And with so many types of metalworking fluids, including some of the ones you just mentioned, soluble oils, synthetics, semi-synthetic, straight oils. Brandy, can you add a bit more maybe about some of the differences between these different types of fluids, and when a potential customer might want to use each different one?
Absolutely. And this is something that these conversations come up with a very inquisitive approach in order to get someone the right answer. So as Mike said, sometimes we're prioritizing more lubricating versus cooling, and a lot of information would be gathered to understand what type of machine are we doing, what is the actual application process, and very importantly, what types of metals are we using? Because depending on what we're working with and then what we're working towards, you may be looking at soluble oils, which are oil-based concentrates that are emulsified with water. So they're versatile, but they can be prone to bacterial growth. Then we've got semi-synthetics and synthetics. Another way of wording that would be oil containing or, synthetic. Just kind of a different understanding of what is making the coolant. So sometimes your synthetics, which are water-based with no oil, may be ideal. It depends also on somebody's personal preference. A lot of times maybe they just feel, I prefer using full synthetics, or I prefer using semi-synthetics. Sometimes it can be a personal preference. And this is where it helps to loop in those experts. We have a really great team of application engineers that can help kind of guide us and say, if you want to go this route, here's what I recommend. If you want to go this route, here's what I recommend. And here's why, really understanding the aspects of what your metals are going to do and how they're going to react and what you're trying to get done and accomplished with your machining operation.
That's great. Thank you, Brandy. And, at SME, with our membership and our audience, obviously manufacturers are a huge part of that, and many of whom will be listening to this podcast. So from the manufacturer standpoint, when it comes to selecting the right metalworking fluid, what are the key factors that they should take into consideration and be thinking about when they kind of begin that process?
So as I said, Brandy and I are the ones who get to have the fun. And for me, fluid selection is a lot of fun. And I think it's key to also be, if you can, visit the facility where you're making the fluid selection is also perfect scenario. So what I'd like to do is kind of like, imagine yourself in front of a CNC machine, and you're just looking at the machine operation itself. And Brandy did touch on this a little bit. So you kind of want to know, what kind of material are they machining? And then you look at the type of operation they're performing. Is it cutting? Is it milling? Is it drilling? Is it gun drilling? Is it reaming? It all depends on the operation too. What are the surface finish requirements that they're after? What is the tool material they're using? And this is all when you're looking at the CNC machine. What is a coolant delivery method? Are they flooding the part with coolant? Are they spraying it? Is it through the tool delivered? Is it a combination? Is it MQL, which is minimum quantity lubrication? And finally, what is the operator's preference to use? So those are what you look at when I'm looking right at the machine. So then I'm going to back out a step, if you will. So you kind of look at the machine now, back out a couple steps and look at the wider operation that's going on. What's the incoming material look like? Is it a raw material? Is it bar stock? Is it rusty? Has it been treated with a corrosion preventative that's going to get into the coolant? Are there breaks or staging while the parts are being machined? Are they going to sit for a week? Or are they going to just go right on to the next operation? Are they going into a wash stage after? Are they going directly to the customer? And is the coolant itself, the metalworking fluid, being filtered or not? Or is it just kind of just circulating around right in the sump there? And finally, if I'm not going too far here, let's back out a couple more steps. Get the big picture of the factory or machine shop there that we're in. Are there environmental requirements there? What are the disposal methods? For the coolant that is it going to be hauled off? Does the plant have a wastewater treatment facility? Does it go right to the local, a POTW, the municipality, if you will? And how do they handle the material in the plant? Are they moving around totes? Is it a bulk handling system with pipes that run to each machine? Is it pre-mixed, or are you mixing it right at the sump? So I know these are a lot of things I'm listing, but these are all the things you take into consideration, along, of course, with the operator or plant preference that you make a recommendation with. So there's really no one ideal metalworking fluid, but it's the right fluid, depends on these numerous factors that I've discussed.
I would also add in, I know this is a very long list, but that's kind of the beauty of taking each case by case and understanding the big picture. Like you're saying, we're not just standing right in front of the machine and getting an idea of, all right, what are we working with and what do we need to accomplish, but taking each element of your overall business, because we want to improve not just your, part finish, but your overall operation. And one other element that comes up a lot is your water. something that often gets overlooked. And, we can look at your water source and understand, are we dealing with treated water? Do you have a reverse osmosis or deionized water? Do we have just straight city water that we're using? Because when we are working with metalworking fluids, your water source and how much hardness is in that water makes a big impact on the performance of your coolant. A lot of times, if we're dealing with foaming issues, this can be a culprit of softer water. So when we look at your operations and understanding, does this area have harder or softer water? Do you have treated water? This can all also go into our overall recommendation. And one other thing that I would add to, the very long list of things that we like to discuss is what's realistic for the customer? What is realistic for your maintenance? And, are you dependent on a coolant that you can kind of set and forget and you need it to just do its job? Or, can we get a little bit more detailed, and are we on the ball with our maintenance? Are we checking concentration every day? So also to understanding what style of, dynamic are we working with at the customer site, and how involved are they with everyday maintenance and having PM schedules coming up regularly. There's definitely been a couple customers that have said, look, I need a set it and forget it. I don't have operators checking concentration. Just give me something that will work, that I don't really need to think about, versus other folks that really are checking every day, keeping maintenance up to date. And maybe we're working with a coolant recycling system and we want to make sure that everything is working cohesively there. So yes, so many different things can come into, the key factors that the folks should consider, and getting somebody like Mike involved and myself in the conversation can help identify what are the things that we need to look out for this specific case. What should those key identifiers be?
Thank you both for such a thorough answer. And it just, it goes to show what a complex decision-making process that is, and how many key factors go into that selection. And that's a great segue into the next area that I want to discuss, which is performance. Once manufacturers make that choice and select the fluid that's right for them, how does the right or wrong fluid impact things like tool life, surface finish, even cycle time? What are the effects that manufacturers start seeing once they've implemented their selection?
So, gather as much information as I can from the actual operator. What are they trying to do? What are they trying to accomplish? And then what's worked in the past, or maybe where are the areas for improvement that they see. So, there's a lot of things that can impact the tool life, surface finish and cycle times and things like that. Chip load is a big thing. The pressures that they're using on the CNC machine, are they using a high pressure pump, or is it just a standard, 40, 50 PSI type of thing? So there's a lot that goes into the performance. As far as the tool workpiece interface, that's going to depend a lot on the material that's being machined and the type of tool that they're being used. So the harder material that you're using, where you're taking off, where you're actually cutting apart, you're going to want to use a higher performance metalworking fluid there. So these are going to be the ones, if you're in the soluble or semi side, the ones that have a higher oil content. If you're in a synthetic realm of things, then you're going to want to use the ones that have a higher synthetic additive content to them. On the other hand, if you're grinding, what you're more concerned with is less lubricity and more cooling. So you want to take into account what concentration you're running at. Grinding typically runs at a lower concentration than a heavy machining operation. And so, the cooling is better there, and the chip removal more so than the lubricity. So I guess that's kind of where I start to focus things on, the impact of tool life, surface finish, and the cycle times and things like that. So performance is definitely key.
Great, thank you. And the flip side of that, I guess, of performance is maintenance as well. So once a fluid is in place and being used, Brandy, maybe you might want to take this. How can shops monitor the health of the fluid and know when it's time to change or adjust it to make sure that it's at optimal performance?
Yeah, that's a really important conversation to have, and where it's good to understand, good level of expectation on how a shop might be working. And then our recommendation is, if we can just give a little bit more attention to the detail on our coolant. One thing is daily concentration checks, using a refractometer and checking the reading on that. That's something that we've actually taught on site. Maybe operators think that, it's a simple tool, or it hasn't been calibrated in 6 months. And actually your concentration is off quite a bit. And having your concentration out of place, whether it be too high or too low, can have a drastic effect on your coolant, on your machine, on your parts. It can wear your tools. It can wear the seals and all the pieces that are actually inside the machine. You can get clogged up lines. And it might be simple to think, just the coolant's not working out and we need to do a switch. But when you can check the concentration and say, actually, we're kind of way off here. If we get that dialed in, having proper concentration at what the supplier's recommended number is, not only is going to give you the best performance for your part finish and your tool life, it's going to improve your sump life. It's going to keep your biostability in range, right? That in the coolant makeup, that's when we look at what is the range of the concentration and why is it recommended to be there, they have calculated this number very accurately to ensure that you are getting the most out of your coolant. And that's going to improve things like foaming on top of all of your overall maintenance. So number one, long-winded answer, checking concentration can help keep you out of a world of problems. And then looking at overall preventative maintenance. So a PM schedule is something that we always recommend. And this can be case by case. How much chip carryout are we dealing with? When we do a full changeover and we have fresh new coolant in a machine, and we're checking concentration every day, you can kind of get an idea of what we're working with, what type of operation we're doing, how much swarf buildup is in the machine. So that's going to be like the granular little kind of sand-like fine pieces of metal, the bigger chips, how much carry out that is, how much, tramp oil contamination. This all, again, case by case. Some manufacturers might need a PM schedule as often as 6 weeks, where some can go 6 months or longer. And this would be just assessed by the condition of the sump and, what we're working with here. So a lot of these changeovers can be as simple as a machine clean out and refill with maybe someone has a recycling system, so we can reuse and reintroduce some filtered used coolant and top off with new. Or maybe we need to do a full changeover, every 6 months or however often. And on top of that would be knowing when to change or adjust is if something seems more labor intensive than it should. Something that we shouldn't have to deal with is a lot of additives. I've worked with customers that are just kind of used to adding in scent tablets because the coolant has a smell. Coolant should not have a smell. You shouldn't be dealing with something that smells like it's rotten, or maybe there's bacteria in there and you're dropping tablets in to deal with that, or if there's foaming issue and we're just dumping an anti-foam. Let's get to the root of the issue and look at how we're doing the maintenance, because it shouldn't be overcomplicated with all the extra additives or all these other steps just to keep you moving.
Great. Thank you, Brandy. And um, we've just been talking about, fluid health and machine health. And the other side of that, of course, is the human side, human health and safety in interacting with these fluids. So, Mike, from your perspective, what should operators and managers be aware of when it comes to exposure and handling of fluids and protecting their own health and safety?
Yeah. So this is a very important part of the business right here. So what I like to do is the best defense, and I say defense against, I guess offense too, for operator acceptance, is proper training on the correct handling and uses of metalworking fluids. So key factors in that are proper maintenance of the fluids, like Brandy just did a great job of talking about, and also proper maintenance of yourself. How do you show up to your machine in the morning, and how do you protect yourself? Back to what Brandy was saying on the concentration, are they under control? Are you maintaining the fluid properly? If you were to chart your concentration, does it look like a sawtooth graph where it jumps up to 15% one day and down to 2% the next day because you're using fluids and all that? So all these things about control really relate to the health and safety of the fluid. Each MSDS will contain the proper PPE, personal protective equipment, to use with those fluids. But I think a metalworking fluid specialist like Brandy or myself showing up and actually training operators on the correct handling and the correct control and the correct usage of the fluid goes a long, long way. And like I said, is the best defense against having things come up later on down the road, like dermatitis or irritation or those kind of things. So I would really stress proper training.
I want to kind of switch gears here. We've been talking about fluids and machining from a sort of bigger picture standpoint, but can either one of you or both of you possibly share with us a real world example, a specific example where switching fluids made a big difference or had a huge impact or had a transformative effect for a manufacturer that you've witnessed or dealt with or helped along in your own experience?
Yeah, it's hard to pick just one. And I would say that in the end, that's the most rewarding part of what we do, is not only, helping solve problems, but to get folks into a better position, because you leave almost feeling like a consultant, right? That came in and you survey everything that's going on and put someone in a better position, from the right recommendation, the right coolant, to the right maintenance and the proper training, like Mike said, and, kind of setting them off to improving overall. But I would say that taking one more recent customer that we did a shop changeover, they switched their coolant. They weren't particularly unsatisfied. Things were working with what they were using, but when we were able to go in and do a full survey, we actually identified some troubles that they kind of were dealing with, right? So they were dealing with a little bit of foam, didn't understand that it could be better. And then when it came to the biggest surprise after a switch, was when they saw firsthand the overall part finish, and how, seeing it side by side, one part that they had that they had finished the week prior, and then a piece that they finished after doing a changeover. And they called me and said, I can't believe my eyes, I'm going to send you a photo, because this mirror finish we're getting on this aluminum, we thought the finish was good before. I didn't even know it could be better, but these are coming out so beautifully. So that is really satisfying, is when you make improvements when things were already okay. It doesn't have to be a catastrophic failure to try to make an improvement, that even when things are working, there's a way to make them better. And I'll just throw in one other piece, is when you can do an overall kind of cost of ownership survey and help someone get to a point that is improving their overall budget. Because when you're experiencing a better finish, you can backtrack that to, how did I get a better finish? Well, it's because my tool part isn't under as much stress. So now my tool life has increased. My machine is performing better. My sump life has increased. That means my downtime from preventative maintenance has decreased. And this all adds up to a better value overall, because that coolant can really impact every piece of your machining operation.
That's a good point, Brandy. I like the use of the total cost of ownership. Cary, sometimes learning the history of why the customer is using what they're using is very helpful. And a lot of times it's kind of an evolutionary type thing, like, well, we've used this fall, the whole time I've been here, and even before that. And there's all kind of different stories of how you get there. But in these coolants that we've talked about, the soluble oils, the semis, the synthetics, even the straight oils, a lot goes into a targeted formulation strategies to achieve the proper balance, within these chemicals themselves. And when you put all that together with the right process, you come out with a real winner. I've had there's a customer that I've got two instances as well. And it was a customer using about a drum per week, so 55 gallons a week of concentrate of a certain product. And I kind of did some investigating. Why are you using this? And no one really had a concrete answer. So we trialed a synthetic. This happened to be a synthetic operation that they could use a synthetic product on. And we trialed it in one machine. Everything looked good. The rust prevention was great. The performance was great. So we kind of implemented that throughout the whole plant. After the trial on one machine, we took their usage down from 1 drum a week to about 6 drums a year. Now, listen, the cost of the coolant per gallon went up, okay? But the total cost of operation went down. So there is a right product in the right place, and this one achieved that. So those are one of the biggest hurdles we come across is, well, how much does your coolant cost? And yeah, I hate starting there, but I do understand that the overall operating budget of a facility is very important. One of the things I learned early on, years and years and years ago, because I've been around a long time, is I got the first day that I showed up for work at a large engine manufacturing facility up in the Michigan area. The plant manager and the manufacturer manager brought me in their office, and they said, "What is your job here?" And I gave them this college answer about how I take care of coolants. And, they stopped me in mid-sentence, and they said, "Your job here is to remove our uncertainties." And I kind of had to think for a minute, and they said, "Go ahead and gnaw on that for a while, but we want you to remove our uncertainties." Well, what I learned from a couple of colleagues that worked there for the customer was what they want you to do is eliminate coolant as a challenge for them in the plant. So find the right product that works for the right operation, be confident about it, put it in, and then maintain it. So maintain the proper process control for statistically speaking. Don't let your coolant run all over the map. So the reason for that, if there's a problem, then they can eliminate that as one of the contributing factors early on. So that's what they meant by removing uncertainty. So long answer, but that's our job. That's kind of our job is what we do is to make things run and run right, as far as the manufacturing process goes.
Thank you. And that's kind of a good segue into the last big question I wanted to ask both of you, which is a difficult one, but feel free to each give an answer or give one answer together, whatever you prefer. If you had to give one golden rule for choosing the right metalworking fluid to a potential customer, what would that rule be?
Okay, so it's all about productivity, and it all ties back to that: cost, usage, operators, materials, everything ties back into productivity. Um, Much more than just machine uptime, scrap, or maintaining sumps, or machine cleanliness and gauging in the whole 9 yards. It all ties in. So I guess my golden rule with that in mind would be to select the right product for the right operation, and that's going to result in the best productivity for you.
100%, Mike. I agree. And I think there's, different ways to say the same thing, but that to me would be my golden rule is, you know, don't do what you've always done, do what's right for what we're doing today with the science and technology that's available today. It's something else that we can look at picking the one that meets today's demands with what we have available today, which is a lot further than where we've been in the past. But many different variations of saying, I would say start with the cut, not the coolant. Go back to pulling back a little bit to observe the situation and understanding the material, the machine, and your goals. Then choose the fluid that's engineered to support the outcome you're looking for.
Great advice. And Mike and Brandy, before we wrap up here, is there anything else that either of you wanted to add or make sure that you mentioned? You've already given us so much information, so it's fine if not.
I feel like we could probably chat all day. Honestly, there's a lot to cover. Something else that maybe folks don't know is a really good way of understanding your coolant and your needs or troubleshooting is doing a lab analysis. So we talked a little bit previously about understanding the makeup of your water, and getting your pH and your hardness and knowing what is in your water. But routine lab analysis on your coolant can help understand a idea of the health of your coolant. And, if there's any built up hardness from too long of preventative maintenance schedules, or if there's any bacterial growth, these sort of, I would add your lab analysis to your preventative maintenance. It's a really good idea to take a look at the health from a full scientific analysis that goes a little bit deeper than putting your eyes on it or just checking concentration.
Thanks, Brandy. And Mike, was there anything else that you wanted to toss in before we go?
Yeah, real quick, I'll make it fast. It's what, like Brandy said, monitoring is key. Monitoring all that is key. And I'd like everyone to take a look at, if you're actually running a machine, take a look at what your turnover rate is to tie into those results. So real quickly, if you have a 100-gallon sump and you want to run at 5%, so you've got 95 gallons of water and 5% of your concentrate. Well, how long does it take you to make up that 5 gallons that you put in? So if you put in 1 gallon a week over 5 weeks, you'd have a 5-week turnover rate, right? So the longer your turnover rate is, the more you're going to see your metrics like concentration, pH, tramp oil, biological control, the more you're going to see those start to fluctuate. So the faster turnover rate will allow you to have better control. But the longer turnover rate will, of course, start those metrics to vary a little bit. So that's where you want to start looking at performance fluids rather than an economical choice, if you will.
Fantastic. Mike Kowalski, Brandy Brown, I want to thank you both so much for joining us today and sharing your expertise. Brandy, you were very humble at the beginning, but I do think you both are experts. I think you've proven that over the course of this conversation. So thank you so much for joining us today.
Thank you, Cary. It's been a pleasure.
It absolutely has. Thank you very much.
And so that wraps up today's episode. And we hope that this deep dive into metalworking fluids has given you, our listeners, a better understanding of how critical the right fluid is to machining performance, tool life, and overall shop efficiency. If you're looking for guidance on selecting the right fluid for your specific materials, operations, or regulatory requirements, don't go it alone. There are experts like Mike and Brandy and resources out there to help. So to learn more or get personalized support, you can visit the Castrol website at castrol.com/metalworking-us. That's castrol.com/metalworking-us, or call them at 888-CASTROL. That's 888-CASTROL. And from rm.sme, to keep up with the latest manufacturing trends and hear more podcasts, subscribe to our podcast feed, and of course, visit us at advancedmanufacturing.org. And thank you for listening to Advanced Manufacturing Now.